Earth is spinning right now. At the equator, the surface of our planet is moving at about 1600 kilometers per hour. That's faster than most airplanes. And yet, you feel nothing. No motion, no force, no sense that you're moving at all. So this raises a simple question. If Earth is spinning so fast, why don't we feel it? To answer that question, we need to understand what Earth's motion is actually like. Earth rotates once every 24 hours. This rotation creates day and night. But that motion is not the same everywhere. Near the poles, the surface barely moves. But near the equator, it moves extremely fast. So in a very real sense, you are traveling through space right now at high speed. At 1600 kilometers per hour, you would expect to feel something. But that's not what we experience. Now compare this to something familiar. Imagine sitting inside an airplane. At cruising altitude, the plane might be moving at 800 kilometers per hour. Yet inside the cabin, everything feels still. Your coffee stays in place. You don't feel pushed backward. That's because you, the air, and everything around you are all moving together. Earth works in a very similar way. So far, we've seen that Earth is moving fast, but smoothly. But this still doesn't explain why we don't feel that motion. To understand that, we need to look at how motion is actually sensed. Here's the key idea. You don't feel speed, you feel change in speed. In physics, this change is called acceleration. Acceleration means a change in velocity, either speed or direction. Think about riding in a car. When the car moves at a steady speed, you barely notice it. But when it suddenly brakes, you feel pulled forward. When it accelerates, you feel pushed back. That sensation comes from change, not from motion itself. So at 1600 kilometers per hour, you would expect to feel something. But Earth's motion is extremely steady. There are no sudden changes, no jolts, no shifts. So far, we've seen that motion alone isn't enough. Now here's the deeper mechanism. There is acceleration on Earth. Because Earth is rotating, everything on its surface is constantly changing direction. This creates what physics calls centripetal acceleration, acceleration toward the center of the Earth. But this acceleration has two important properties. It is constant, and it is very small compared to gravity. At the equator, this effect is only a tiny fraction of the force you feel from gravity. So it blends into the background and becomes unnoticeable. Now combine this with inertia. Inertia means objects resist changes in motion. If something moves smoothly and consistently, your body has nothing to react to. Imagine sitting inside a perfectly smooth airplane. No turbulence, no acceleration, just steady motion. You can stand, walk, and move normally. Nothing tells you that you're moving fast. Earth is like that airplane, but on a much larger scale. Everything around you is moving together. The ground beneath you, the air around you, the oceans, your body. So there is no relative motion between you and your surroundings. And without relative motion, there is nothing for your senses to detect. In fact, if the air did not move with Earth, you would feel constant high-speed winds. But because the atmosphere rotates along with the planet, everything feels calm. Now here's the final piece. Gravity holds everything firmly to Earth. It pulls you toward the center of the planet. At the same time, Earth's rotation creates a small outward effect. But gravity is far stronger, by a large margin. So everything stays grounded, stable, and connected. This is why Earth's motion feels invisible. Not because nothing is happening, but because everything is moving together, smoothly and without change. This reveals something interesting about how we experience the world. Our senses are not designed to detect constant motion. They are designed to detect change. This is why you notice turbulence in a plane, but not smooth flight. Why you feel a sudden turn, but not steady movement. In a way, Earth's rotation is one of the most stable motions we experience. It happens continuously, without interruption, without drawing attention to itself. And this also explains something deeper. We are always in motion, not just from Earth's rotation, but also from its orbit around the Sun, and the Sun's motion through the galaxy. Yet almost all of this motion feels completely still, because when motion is shared, it becomes invisible. If you enjoy understanding the why behind things like this, you'll find more like this on the channel. So why does something moving this fast feel completely still? Earth is spinning at high speed, especially near the equator. But this motion is steady and unchanging. And our bodies do not detect constant motion. They detect changes in motion. There is acceleration, because Earth is rotating. But it is constant and extremely small compared to gravity. So it fades into the background. At the same time, everything around us moves together. The ground, the air, and our bodies all share the same motion. So there is no relative movement to sense. This is why Earth's rotation feels invisible. We are moving at incredible speeds, yet everything feels calm and still. Because motion, when it is constant and shared, disappears from perception.